We are building this beginner-friendly arcade Pong game from scratch using HTML, CSS, and JavaScript. It has a super cool arcade game background which our game board sits inside of. This is a two-player game and the W and S keys control the left paddle while the up and down arrow control the right. The ball starts in a random direction each turn and the game objective is to hit the ball with your paddle before it crosses your side of the game board. When the ball hits a paddle, wall, or the game edge, a sound effect is played, giving the game another layer of life. By the end of this tutorial, you will have learned to create these sound effects using the free website Musiclab. You'll also have a deep understanding of every detailed step as we set up our game logic, as I will be breaking down the concepts in each section of our game before we code it together. We will learn to create and give the game board perspective using CSS transformations, create the ball and paddle elements, make the paddles and ball move on a key press, keep track of when the ball collides with the walls or paddles, and most importantly, keep track of the high score to know who's winning. You'll have learned to create and manipulate HTML elements using JavaScript, simple game logic, game design, and CSS transformations and styling. This project is intended for beginners to JavaScript, as I will be explaining all the code we use to make this game take life. You only need a basic knowledge of HTML and CSS to start this tutorial. We'll be using VS Code as our code editor, an AI-generated image for our arcade background, Google Fonts for our retro font, GitHub to store our code, and Netlify to deploy and host our website for free. As always, you can find the deployed game and GitHub repo in the description below. If you're ready to make your version of the best Pong game on YouTube, let's get started. The first thing we're gonna do is to create a GitHub account if you don't already have one. We're going to use that to store our code. So you're going to go to github.com. You're going to click the sign up button here up top in the right. And we're just going to enter our email, password, and you're going to sign up. Once you've signed into your account, it's going to look a bit like this. We don't need to touch anything for now. And then we're good to go on to the next step, and that is to download Visual Studio Code, which is our code editor we're going to be using in this video. So if you don't have that, go to code.visualstudio.com and you can click the download button. You're going to download the stable build for your device. Once you've downloaded it, you're going to open and run that file and install VS Code. Then we're going to go to desktop.github.com and you're going to download Github Desktop. This is going to help us push our code up to Git using a nice interface instead of using the command line. Download for your device. Once again, you're going to get a file here. You're going to unzip that and run the installer. Then you're going to open GitHub Desktop. It's going to look a bit like this. And you're going to sign in with your GitHub account that you just created. Then you can see your profile picture or avatar down here. And now we are ready to create our project. So we are going to click this arrow here. We're going to say add. We're going to create a new repository, and this repository is going to be called Pong-game. We can leave everything else blank and hit create repository. Then we're going to publish that repository. I'm going to keep this code. I'm going to uncheck that and keep it public because I'll be sharing this repo in the description below, but you can feel free to keep it private if you wish. It doesn't impact your ability to deploy this project later on. So publish repository, then we can open this repo in Visual Studio Code, and that is going to open VS Code for us with our repo, as we can see here in the Explorer tab, is open here. And we have a Git attributes file here. Let's just delete that. We don't need that. So I'm going to full screen VS Code. The next thing we're going to do is we are going to click the bottom tab here, extensions, and then we see that I have a couple of extensions installed here. The only one we're going to need here is live server. So you can find that by searching live server, and then it's going to be the first one with almost 50 million views. This is going to update our code every time we save when we're working locally so we can see the changes instantly in our browser. So you're gonna click the install button here where I have uninstall, and then that should be ready to use. You're gonna get a little go live button down here, which we're going to use later. The next extension we're going to have is Prettier code formatter. So we're just going to search Prettier. It is also the first one with 45 million downloads. We are going to install that as well. Then we're going to open our settings in VS Code by clicking here and extension settings. Now I have a full video on setting up Prettier in VS Code if you run into any trouble. So I'm going to link that here. But essentially the thing we're going to do, let's remove this in the search bar here. We are going to click the text editor. We are going to click formatting. We are going to make sure that this format on save is checked. And then we are going to search default formatter. And then this should be showing here, editor default formatter. And we're going to make sure that Prettier is the one that is checked here. So with those two settings, Prettier should work for you. If not, check out the video. The way you're going to know that Prettier works is let's close the extensions here and open up our Explorer again. We're going to create a new file. We're going to create an index.html file. Hit enter. We're going to type exclamation mark and tab. That's going to give us an HTML boilerplate. Now, if I hit save, this code should get formatted. So if I hit Control S, we see that the code jumped around because Prettier is formatting it based on some default rules. So that's why we're using Prettier. It's going to format our code. It's going to make your code look identical to mine if we've written the same things, and it's going to make it easier for you to follow the video because you're going to see each one of my lines is going to be the same as yours. Let's check out if live server works by clicking this go live button down here, and then there should be an internet tab that just opened for you. In my Chrome, we see that we have an empty blank page directing to 5500 index.html. That's our document here. And as we can see, the title of this document is document. If I change that now, the best Pong game, we see that that also gets updated in our browser. So that's the beauty of live server. We get all our updates on save. We don't have to keep refreshing the page, which we would have to do without live server. I am gonna close the Explorer so we can see a bit better our HTML. I'm also gonna hit Option Z on Mac. On Windows, you can check out what the command is by clicking View up here in the VS Code settings. You're gonna see word wrap. So you're gonna hit that, and that is gonna make the code be visible regardless of the width of VS Code. So now I've opened the finished game that you can also find the link to in the description below. I've opened it up so we can check out what we're going to do. So the first thing, as we can see here, we have a custom font. This is not one that comes by default in VS Code, so we're going to download that from Google Fonts. It has this very gamey font and retro, and I really like it. So we're going to go to fonts.google.com. We're going to write press start, and then it's going to be this press start 2p. Love that font, very pixelated. That's exactly what we're going for. We're going to click this get font down in the right corner. We're going to click get embed code, and then we're going to scroll down, and as we can see here in the link tab, not the import but the link, we're just going to copy that code and we're going to paste that in our HTML above our title. Like so, and now we have access to that font, as easy as that. So now we're going to copy this selector for the CSS class, and we are going to open our Explorer in our VS Code, create a new file, call it style.css, styles.css, and we're just going to paste what we just copied from the fonts.google. We're going to go back to the index. Inside of our body, we're just going to add an h1 and say, hello world. Hit save, and then check out our tab with our local live server. So far it's only a normal text. If we go into the style sheet and we, instead of targeting this class here, we target an h1, hit save, and nothing is happening because we haven't, of course, linked to this style sheet in our HTML. So we're going to add a link dash CSS, and it's going to link to styles.css. And when I save, we see that the hello world turned into this nice gamified version. So now we have access to this font for later use. So we can just delete that H1 as well. And we can leave that for now. Doesn't hurt anything. The next thing we're going to do is we're going to also link to our script that we are going to use later. That's going to be our JavaScript, which we add in the head here below our style sheet. So it's going to be script-src. And I am just using the arrow keys to go into the suggested versions here and hitting tab for the source one. For the source, that's going to link to our file that is going to be in the same place, just right here in the Explorer in the repo. So it's going to be called script.js. Let's now create that script. New file in the Explorer, script.js. If you have never touched JavaScript before, essentially it is the language of browsers and the internet. So here we can do something like console log, and then we can say hi there. And then everything that we run in a console log is going to show up in our browser. So now we have called this console, that's like a function, you can think of it as, and it is saying you're going to log this sentence here that is within these single quotes here. And you can get a hold of that log if you right click on the browser and you hit inspect. Then it's going to open this tab here, zoom in with Control+, and we can open the arrow here and go to the console. And as we can see, here we have the text that I just wrote. Hi there. The console log is a very useful tool when we're checking either for bugs or what kind of data we're working with in our JavaScript, because it might not always be obvious. We can also just leave that console log there for now. It isn't hurting anybody. Then let's go back to our index. Let's not forget to add here an attribute in the script here called defer, which means that we're going to run this script before we run we're going to run the HTML, everything inside the body before we run the script, because otherwise we might run into problems like this. So let's say I say H1 here in the body. We see hi in our web page. That's great. Then I'm going to go into the script file, and instead of console log, I'm going to say document get element by ID. And I'm going to say hi. I'm going to go back to the HTML, add an ID tag here and say it's called hi. So now we know how to reference this element here. I've gave it an ID, which is a unique identifier called hi. And then I am getting a hold of that in the JavaScript. And now let me try to console log this. So I'm going to write console log and put brackets around this, parentheses, and I hit save, and then we see that we get our H1 here. Perfect. Now let me see, when I remove the defer, we get null, because we are running this script and it's being run finished before we get to the H1 here. If we don't have the defer, we would have to put the script here after the body, and then that's not very good. You end up having like lots of script down here. You might miss some of them. They start to be difficult to keep track which one needs to run before the other one. You avoid all of that by simply putting the script in the head and adding the defer property. Okay, great. Now I'm gonna remove that from the script. Go back to our HTML. I am going to remove the ID from the H1 here, and I'm going to give it a class instead. And that class is going to be title. And here we're going to write Pong in big capital letters. The reason I gave it a class instead of title is because we're not going to use this element, this H1 here, in our JavaScript. And a nice rule of thumb is if you're going to style this element, use classes. If you're going to manipulate it using JavaScript, use an ID. JavaScript needs to know which exact element to use, and IDs are unique to only one element, and classes can be on many elements. And I would avoid, if possible, to use classes in our JavaScript, and I would avoid, if possible, to use IDs in our CSS, although both are possible. And one reason to avoid using classes and IDs in our style sheet interchangeably is because it makes it a bit harder to know which styles take precedence over the other ones. And to give you an example, if this one had an ID as well of title, and if we now styled the class in our style sheet and you gave this a color of red, but then later in your style sheet you also style title and you give it a color of blue, the style for the IDs is going to overrule the style for the classes. And if you target the H1, which is the element, that's going to overrule both class and ID. If you can avoid using IDs to style, it's going to help you avoid making mistakes like that, and it's going to avoid overriding a lot of styling unintentionally. Of course, sometimes the most practical thing is to do exactly the opposite, so take that with a grain of salt. The next thing after our H1, we want to add a span element, and this one is going to have a class of score, and it's also going to have a second class of player1 score. And you might be wondering, if you're not that familiar with CSS, is here I'm giving them two classes. That is completely fine. You can give them a million classes if you want. HTML elements can have as many classes as you want, and classes are not unique, so they can be shared among however many elements you want. It is, though, also going to have an ID, because we are going to be manipulating this player1 score later on when player1 scores. So then we're going to use this ID to target it in our JavaScript so that we can increment the score going from 0 to 1, from 1 to 2, etc., etc. So this is just going to be called player1 score as well. And there is no problem in having a class called the same as the ID because they're not being used in the same place. So we're going to initialize that to 0. And you can see that here in a very, very tiny, I'm going to zoom in a very tiny 0. And I'm going to make our code screen slightly bigger, our VS Code. Then we are going to create the same element for the player 2. On Mac, you can hold the Shift option. On Windows, I think it's Shift and Alt. And you can hit the down arrow. And that is going to copy the entire row that you were on with your mouse. And here, another cool hack is if you target the 1 and then you hit Command D or Control D on Windows, I believe, you're going to target the next instance of whatever you hovered over. So that's going to be 1 and 1. And now we can just write 2, and now we have saved us a bit of typing. Next thing we're going to create is an H3. This is going to be a class called startText. It is going to have an ID as well of startText. And here we're going to write in press any key to start the game. So that's what we can see in the finished result here. That's our start game text in the middle of the screen here. That is going to disappear when we actually start the game. And that's what we're going to use this ID for, is to hide and show the start text. Next up, we're going to create a div under the H3. It's going to have a class of game area. And that is going to be the square here that we are actually playing inside of. As we can see, we have one paddle, two paddles, and a ball, and we also have a net inside of the game area. Then it also has a border, which we're going to give to this div. So let me just scroll down a bit. The first paddle is going to be a div. It's going to have an ID of paddle1. It is also going to have a class of paddle1 and also paddle, because that is going to be a class that is going to be in common between both paddles. The same is true for score. It is going to be a class that styles both player 1 and player 2 scores at the same time. That is why we tend to use these general classes. There is not going to be anything inside of the panel. So now we're going to hit Shift Option or Shift Alt and hit down again. And same thing, Control D or Command D on the 1 and press 2. And now we have our second paddle. We're going to create another div. This is going to be the ID of ball and class of ball. That is, of course, going to be our game ball. And then last one is going to be class of net, which is going to be our dotted net in the middle. So let's get back to our actual tab here. We don't see the game area or any of the children elements here because we haven't given them any height or width or background or any styling at all. So they're going to show up later once we actually start styling them. After the game area, we're going to introduce the image, and that is going to be this image here that I have already pre-made using ChatGPT, or the Dolly version of it, that is already generated an arcade machine. So back in our browser, we need to actually access that. So in the description below this video, you can find a link to the asset folder for this project. When you click that link, it's going to lead you here. You're going to hit the code, green button here, download zip. Inside of that zip, there's going to be an asset folder, and you're going to just drag and drop that into your VS Code, into your repository explorer, and you're going to copy the folder. When you open it, you see that you have lost.wav, machine.png. Also, I don't know if you say it wav, but that's how I pronounce it. Wave, paddle, and wall. So these are the 3 different sounds that we're going to be using for our game. If you play it, you can hear the wall sound. You can hear the paddle sound. I'm later in the tutorial going to show you how to create your own sounds if you would like to tweak them or use completely different sounds for your game. You can close the zipped folder, get back to our game. Now we can actually link to the background that we have in our asset folder, which we can access by writing /assets and then machine.png. For the alternative text, we're going to write arcade Pong machine. And then if I close the inspect here, we can see that I've gotten a very, very large picture here because it's a very big picture. But we are going to make it much smaller using CSS. Then this image is going to have a class of BG for background. Then under the background, we're going to add another div. It's going to have the class of vignette, because as we can see here in our finished game, there is a slide, that's what it's called, a vignette, and that is it gets darker the further out from the center you go. So it's more visible if I make the screen smaller, and you can see that the edges of the arcade get slightly darker and the center is very bright, and this gives this nice focus effect on the center stage, which is our game. I'm going to inspect the finished game here, and I'm going to try to hide this vignette. Let's see, width, height, and now we see that it looks a bit more flat without it. So that's why we're adding this. It gives it that little depth, and it gives it a bit more of a real 3D feel, I find. So that is going to be styled completely through CSS. And then lastly, in our HTML, we're going to add 3 audio files. And those are just going to be lying here and be ready to be played on cue in our JavaScript when we hit the paddle, hit the wall, or when the ball crosses the border and the player loses. So the first sound is going to be /assets, and that is going to be the paddle sound. We're going to give this an ID of paddle sound. Then the second one is going to go into the assets and going to be the wall with an ID of wall sound. And then the third one is also going to go into the assets and be the loss sound. loss sound. Okay, so that is everything for our HTML. We are ready to style it. So the next thing we're going to do is we're going to style the elements first, and then we're going to go into our JavaScript and actually make them move and interact step by step. Let's open up our style sheet. Then we are going to take away this h1, or in fact, we can just change it to the body element. So the first thing we are targeting is the body itself, containing every other HTML element. So now that I changed that, you can see that the font family has also changed to use the press start to play font. Then we're going to remove the font weight and the font style. So we're just going to keep the font family. If we don't have press start to play, we're going to use the system UI as a fallback font. Next thing is we're going to add a height. So we're going to say that the body is going to be 100% of the device view height. So it's going to take the entire screen for however high the screen is. We are also going to add a margin of 0 to basically remove these. If I right click here on the Pong, we see that we have, and then on the body, we see that we have these orange margins. So we're just going to reset that to 0 like so. We are going to add a display flex. The goal here is to center the background, because we are going to position all the various text here in an absolute way, which means that they're not going to be positioned compared to other elements, other sibling elements at least. They're going to be positioned kind of on the screen compared to the view width and view height. But we want to position the background layer in the center. So that's why we're adding the flex here in the body. So flex direction is going to be column. And here we see our background image. We're going to align items to the center so that they are centered horizontally, as we can see. Then we're going to have a background color of #111, which is quite dark, but not completely black. As you can see, completely black is the text, and this one is slightly more gray. I also have a separate video on Flexbox if you are not very familiar with it, so you can watch that here before you continue if you would like to. Then we're gonna give this body and all the text inside, we're gonna give it a white color. But I don't want it to be completely white because it doesn't look so good. If we go to the finished version, having it completely white makes it look a bit separate from the arcade background. So I'm going to make it slightly transparent so that it blends a bit more with this background. So back in our version, I am going to click this white color here, and I'm just going to turn down the opacity a bit. And then we get the color displayed in the RGBA value: red, green, blue, and then alpha for the transparency. So this is going to be set to 0.9. So that is going to give us a bit more. If I set it to 0.5, we see that it gets quite transparent, but 0.9 just gives us quite white, but not completely. Then lastly, we are going to set the overflow to hidden so that we don't get those scroll bars because the image is overflowing the screen width. I'm also going to zoom out to the original size now, just so we can properly see how we are styling things. So you'll have to excuse if it's not as clear to see what it's written on this screen, but in order for us to properly style what's going on. Then let's get a hold of the game area, our actual place where we're gonna play the game. So targeting the game area class that we made earlier. And we are gonna, as mentioned earlier, we're gonna position it in an absolute way. So we don't see anything yet because we haven't given it a width or a height. So let's say 600 pixels and then height of 400 pixels. I've already played around with the width and the height of the game and the background in general to find something that I found looked good. But feel free to change this to what you find looks better. So background, we're gonna give it an RGBA of the same as we did earlier. So now we can see it. If I remove the absolute position, it's gonna be below. But now we see that it is free of all the other elements. We're not gonna make it that solid, so 0.6. And we're also gonna change the colors. So it's gonna be 7 here, and 26, and 49. There we go. And then we're gonna position it from the top, 182 pixels, like so. Then let's target the background and give that also a position of absolute. Let's give it a height of 1,000 pixels, not 100, 1,000 pixels. Okay, that looks great. And then let's move it behind the game area. So we're gonna give it a Z index. This decides which item is in front of the other. So by default, everything has a Z index of 0. So we're just gonna give it a Z index of -1. And as we can see, that moves our game area in front of the background. If we change that to 1, we see that it goes in front again. Okay, so now let's try to align the corners of the game area onto the corner of the background. And as we can see, we need to transform this game area because it's slightly tilted away from us. And I'm going to show you how to do that. First of all, let's give the game area a border. Let's see, a border, actually, so that we can see a bit more clearly where this game area is. That is going to be hashtag 919 BBEC 7. And it's going to be 10 pixels wide, and it's going to be a solid border. There we go. Bit easier to see. So as we can see, the background has a tilted square, and this one is completely horizontally and vertically straight. It looks straight on us with 4 90-degree corners. We are gonna add a border radius on our border here of 4 pixels, just round out the edges a bit. And we're gonna give it a backdrop filter. So it's gonna blur whatever is behind this game area. So blur and then 4 pixels. As we can see, it blurs it. So if I put more, it is more blurred. So we're just gonna blur it a bit. I find that this effect gives it a bit more of a glassy look and as if it's in a glass frame inside of this arcade game. Then we're going to switch screens here, and I'm just going to explain quickly how the next transformation we're going to use on the game area works. So this is our screen currently. Then we're going to give it something called a perspective. So if we imagine on the left here, that is us, and we are looking at the screen like this. And the screen is away from us. So the screen has a direction, it has an X axis, and it also has a Y axis. And then when we are looking at it, the direction between us and the screen here is the Z axis. So this perspective here that we're going to give it, that is going to stand for the Z axis. So that's going to be how many Z pixels are we away from this screen? So that is number 1, that's the perspective. The number 2, that is going to be rotate. And that is going to be rotating around the X axis. So this axis. So if we imagine that we're seeing the screen here, again, this is just a copy of the screen, and the X axis goes like this, we are going to be rotating it around like so. So it might go a bit backwards or a bit forwards. So we are going to give this rotate a certain degree. So this rotate is going to get a degree. The next thing we're going to do is we're also going to scale both in the X and the Y. And that simply means that we're going to make the sizes of the game area, despite it having a fixed pixel size. So I think it's 600 that we gave it pixels and 400 in height. We are going to actually scale it so it's going to look smaller. So the real size is going to shrink or stretch. And those three things combined will make us be able to position this screen in a way that it looks like it fits inside of the arcade game machine. Back into our game area class, we're going to add the transform, and then we're going to add those four actually attributes we just talked about. So the perspective, we're going to say that this screen is 1,000 pixels away from us. We are going to say that it's going to be rotated around the x-axis 33 degrees, as we can see. Then we are going to scale it in the x-axis 0.4 of its original size. We're getting there. And then we're going to scale it in the y direction to 0.84. Now, obviously, I'm not like guessing all these values and it's looking completely right. I have played around a bit with it. But if you are, unsure how to do it, let's say you started with 20 or 10 and you see like, okay, it's not enough, maybe 40. Well, that's too much. Okay, then we just like basically experimenting. 30, it's still a bit off. 31, it's getting there. 32, honestly, it could be 32 as well. 33, that's looking about right for me. So it's just about tweaking it until you see that it fits. So now we have our game area completely aligned with our arcade background. Then we're ready to actually make our paddles appear on our screen. Now we're going to target the paddle, and then we're going to give that a height of 100 pixels. So if you remember in our HTML, paddle is the common class for both paddles. And then we are going to give them a width of 20 pixels. Well, where are they? Well, we need to give them a background. And it's going to be an RGBA of that almost completely clear white. So there we have it. Then we're going to give it a position of absolute. And notice now how, because we gave it a position of absolute, now it's shrinking and actually taking the perspective and the scale from the game area, which is its parent component. Otherwise, it was scaling according to its real size. Now both paddles are here. We want to obviously move the right paddle over to the right side. Let's also give them a top of 150 pixels to put them in the center. It's 150 because we have the height here, which is 400, and 400 divided by 2 is 200, but then would put the start of our paddle a bit lower down, so we have to minus that with the half of the height of the paddle, which is 50. So 200 minus 50 is 150, and that puts it completely in the center. Then we're going to target the paddle 2, and we are going to say that it is going to be from the right 0 pixels, and that moves it over to the right side. Then we're going to target the ball class. We're also going to position that absolutely. We're going to give it a height of 20 pixels and the same for the width. Also a background, which is going to be RGBA and the same off-white or almost completely clear white. Then we're going to give it a border radius of 2 pixels, like so, to also smoothen out the edges of the ball, which is actually a square, but in this retro Pong game, it was a square. So That's what we're going for. It wouldn't look retro if it was completely circular, but feel free to put your own spin on it. Then we are going to put it from the left 290 pixels. Again, it's the same thinking as with the paddles. Half of the screen width is 300. So minus half of the width of the ball will put it completely in the center. And the same thinking for the top, 190 pixels. There we go. We have centered our quote-unquote ball. Then let's create the net by targeting the net class. Position of absolute. Then let's give it a border right of 8 pixels. RGBA and then the same color, but we're gonna decrease this to 0.3 so that the net is a bit less visible than the other elements because it's a bit more in the background. And then dotted. And then we're gonna give it a height of 96 pixels. There we see it on the left side here. We're gonna give it a left of calc. So here we can calculate inside. It's going to be 50% of the width that is available minus 4 pixels. And the height is of course very small because this is not supposed to be 96 pixels. It's supposed to be 96%. It's 96 because I find that it looks a bit better if it's not completely all the way into the border. It looks a bit more like it's inside of the game area. We're also going to move it halfway from the top, so 2%, because 100% minus 96, that leaves 4% left. So on each side there should be 2%. So if it's 2% on the top, it's 2% on the bottom as well. And now we have centered our net. There's another thing I want to add to our ball here. I want to add a box shadow so that we have a bit of a shadow under our ball. So we're going to have 4 pixels, 10 pixels, 4 pixels, and then the RGBA like so. Just that we are going to remove the 255 and just add 0 instead, because that's going to make it go from white to black. And now the ball has a bit of a shadow behind it. You can also choose to put some shadow on the paddles. Also change the shadow, change the spread, make it smaller, more distinct, or remove the shadow completely. Then we can target our title, so our Pong here. Let's actually center that and put it inside of this round area here. So we're going to position it absolute, freeing it from the other elements. Then we're going to say it's going to be 88 pixels from the top. Again, this is a value I have played with that looks good. And we're going to say font size is going to be 26 pixels. We're going to do the same with the score. We're going to position them absolutely. We're going to say from the top, you're going to be 88 pixels. We're going to display you using Flexbox. We're going to give you a width. And I'm going to explain shortly why we're doing this. Like you might be wondering why we're giving width and height to text elements. Let's just get them visible here. Justify content, center, and then align items to the center. Where are they now? Have we forgotten to give them some kind of... we should probably put them where they should be. Let's see. Player 1 score left calc 50%. I think I see it. It's in the middle. Minus 200 pixels. I don't see it. Let's inspect our score here. Okay, so they are in the center here, left. Okay, so I think the problem, okay, it was actually just a typo. Minus and 200 needs to be separated inside of the calc function. You have to separate the all the elements, otherwise it does not work. And that was the missing thing. We can see our 0 has showed up. So to explain then why we are giving them the width, height, and the justify content. So as you can see, when I am hovering over player 1 score, we see that there is this purple box around it, and it is filling kind of the circle which the text is within. And I've done this because, and I've given it a width because otherwise, when the score iterates, one like goes to 0, 1, 2, 3, and then especially when it goes to double digits, and especially if you then go to triple digits, this score is gonna go from here and it's gonna go out to the right. But since now we have given this a width, a height, and then in addition, we have justified the content and aligned the items, then this score is actually gonna stay in the center of this circle, despite it getting 2 digits, the digits having different widths, or even 3 digits. So it's always going to be centered within this circle. That's why we're doing this. That could seem a bit like pointless now when you just have zeros. So to display that, let's put 100, save. Well, that's 1,000. Well, it's a good example. You see that it's still centered. And let's put that back to 0. And let's zoom that out back to the proper size. We are gonna do the same for the player 2 score. Same and same. This one is gonna be from the right. So calc 50% minus 200 pixels. And that moves it perfectly where it needs to be. Then we're gonna target the start text. So the start text class, position of absolute, margin of 0, top of 50%, and we're going to give it a z index of 1 to make it in front. We are going to put it from the left 50%, and then we're going to bring it back because now the start of the text is 50% from the top and 50% from the left. But that doesn't make the text actually look 50% in the center. So we need to translate this and translate, which is basically move it minus 50% of its own width in the X direction, and same in the Y direction, like so. So now it is in the center. If we then also text align it center, then we see that it's quite centered actually. It might look like it's a bit lower, but that's just because of the background and the way it is kind of more top heavy. Then we're going to give it a background of #222 to make it easier red. And we're going to give it a border radius of 4 pixels. And a padding between the text and its background of 10 pixels. And there we have our start text. It's looking very similar to the finished product. Okay, we see that we are lacking our vignette. So let's target that. Height. And that is going to be 100% of the device view height. The width is going to be 100% of the device view width. Then we're going to give it a background. And this is going to be what is called the radial gradient. So here we are going to create a circle. The start of the circle is going to be RGBA. It's going to be 0, 0, 0, 0, so completely transparent, from 50% out. So we are starting, if this is 0% and this is 100%, or from the other side, 0% is in the middle and completely to the right is 100%, then the circle starts at 50. So here is where the circle starts. everything inside of it is completely clear. Okay. We also have completely white, transparent color here. If you click the color, you can always see what it is. So it's going to go from that to the third value here. The first value is what kind of radial gradient it is. It's a circle. Then it's the starting value. Then it's the ending value. So RGBA. And here it's also going to be 0, 0, 0, comma, 0, comma, 0. And then 1 at the end. And this is going to be at 100%. And this is not working because we have a extra parentheses here, and it should in fact be after the 100% there. And let's save. Prettier also formats our code, and as we can see, the vignette has been added. So if we comment that out, we see that it has been added. So I'm commenting using Control KC, and if you hit it again, you uncomment. Or Command KC if you're on Mac. So there we see our vignette. Here it looks a bit, it still looks good, but here it really gives it that like, ooh, I don't know. I feel like it makes a very big difference, but maybe that's just me. Let me know in the comments if you agree. It is looking really, really good. I think it's identical. Yeah, changing between these really doesn't give any sort of difference. So yeah. We have all our styling. Let's now take a moment to just describe what we're going to do in the JavaScript in order to make this game run and function. And it's just going to be a top level introduction to the logic we're going to create. So overall, the Pong game, the Pong logic is this. So we have one paddle on the left. We have one paddle on the right. Let's call that R, L, and then around those, we have a game board. Those are the walls. And then we have a ball in the middle. How do we make it run? Well, number one is we need to actually make it run. We need to start the game. Start game. And then we need to define what is actually a start game. So, well, we're going to have a couple of variables. We're going to have actually, something like is game running. I'm gonna name it better. So is game running? That's gonna be like true, false. So that's one thing. And then if we start the game, we're gonna set that to true. If we stop the game, we're gonna set that to false. Okay, so that's number one. Then what? What if the game is running? So if run, then we're gonna do some logic. We're gonna create a function that does some logic, and it moves all these little pieces like so. So if we start the game, we click the start here, then we're going to run all these functions here, and that is going to make all of these things move. Well, how do we actually do that? Well, we're going to use something called a set timeout. And this set timeout is we're going to run that in 8 milliseconds at a time. So every 8 milliseconds, we're going to run a piece of code. And then in the next 8 milliseconds, we're going to run it again and again and again and again. And that is going to be our frames for this game. So then for each frame, this ball is going to run. So number one, we have start game. And that runs our piece of code every 8 milliseconds. So for every 8 milliseconds, we can move our paddles up and down. And then the ball is going to move by itself in a random direction. And that's basically all to it. Then step 2 is figuring out when do things hit each other. So when hit. My handwriting is getting worse by the second. So when does the ball hit a paddle? So that's the right paddle. So then we're going to have to keep track of the balls. So this is the ball X position, and it's going to be moving throughout the game. And we're also going to be keeping track of the ball's Y position. And in this way, we can keep track, if we also keep track of the paddle position. So this is going to be the Y, and then the X here. So this might look a bit complicated, but it's really not, because we are going to be taking it step by step, building it frame by frame. And once you have gone through the whole JavaScript, you will actually understand every single piece. And I'll be explaining more in detail all the different elements, like the ball and, you know, the paddles and the 8 milliseconds, as we are building each part. Okay, let's jump into our JavaScript file. And here we are gonna create some game variables. So like we just mentioned, let me also just comment this, Command KC. So here we're gonna create some game variables. And I'm commenting that out, Command KC. And in these game variables, we're gonna have, you know, we're gonna store if the game is running or not. We're gonna store the coordinates to the paddles and the ball, the speed of the ball, etc., etc. So, but we're gonna start slow. We're gonna just create a variable using the let keyword. And we are gonna create a game running variable. And we are gonna initialize that variable to be false in the start. So when we open our game and it is at this screen, the game is not running, which makes sense. So if we inspect here and we go over to the console, now I can actually get a hold of this variable. So if I type game running, hit enter, we get back false. If I write true here and I do it again, game running, hit enter, and we see that true is logged. So we are initializing a variable here to false. Then we are going to actually create our start game function. So here we're gonna have start game, and this is going to be a function where we create functions using the function keyword start game. And then this function has the name start game. It has these parentheses, and if we wanted to, we could send in an argument here, argument 1, argument 2, and then we can use those arguments inside of the function body here, which are inside of these curly brackets. But we're not going to do that. These functions, for mostly we're going to be using in this game, are going to be quite simple, so we're not sending in anything. What we are doing, however, is we're going to say that the game running that we have defined up here globally means that it lives in the uppermost layer of our script, whilst everything inside here lives locally inside the start game function. So we're saying that the global function game running, the global variable game running, is going to be set to true when we run this function here. In addition, we are going to target the start text here, and we're going to hide it. So in order to do that, we need to actually get a hold of it from the HTML. And the way we do that is we are going to create JS representation from the document object model, which is essentially the HTML document we have. So we are going to say constant, because this is not a variable, this is a constant. It's not going to be changing. The content within the constant might change, but the constant itself is this element. The fact that it exists means that it is not changing in a way. So we are going to say start text, is that what we're calling this constant, is equal to document. We're going to go into our HTML document. We're going to say get element by ID. And then we call this, if we go to the, let's see, text, 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 start text. So the ID is start text. So we're going to copy that and paste that in here inside of single quotes. So now the const start text, if we log that here, log start text, and then we inspect here, we see that we get this whole element. And if I hover over it, we see that it is displayed here. So we are accurately getting a hold of this, this element. So then inside of the startGame function, I'm also going to get a hold of the start text, and I'm going to set the style of it and the display. So now in a way, instead of going through the CSS file, I'm saying dot style. So now we're in the CSS, and I'm saying display property. So that's the same as if I were to go in here and give it a display. A display here. But instead, we're doing that in our JavaScript. So that's going to be equals to none, which essentially hides the text. So now let's run our start game and see if our game running is set to true and our text disappears. So let's save. And as we can see, the text disappears and our game is now running. So if we inspect and then we type game running, hit enter, we see that it's true. Perfect, we've started our game. So obviously we're not gonna just start the game like this. It needs to start on our command. We want to start, as we can see here, on any key press. So we need to actually listen for key presses. So just above the start game function, we are gonna have an event listener. So we're gonna say document, again, targeting our HTML file. We're gonna say add event listener. And here we're gonna give it a first argument. And that is gonna be, we're gonna listen to what kind of event. So here we have some options. Key down is gonna be the event. So any key that we press is gonna be listened to here. And when a key down has happened, we are gonna run start game. Like so. So now we don't have to call it directly here. Let's hit save. And now, as we can see, the text is not disappearing, so we can know that the game is not running yet. If I hit a key now, I just hit the key and it starts. Now I'm gonna hit Command R to reload the website. I'm hitting W, starting the game. S, starting the game. T, starting the game. And I'm resetting every time. So as we can see, we are successfully starting the game on a key down event. And we can even see, I'm just going to remove this start text log. Then once we have started the game, we don't actually want to be continuously listening for this event here, because that would start the game over and over again every time we hit a key. So let me show you. So if I log here, game, actually let's log start, just a string start, the text, and I inspect here, then watch what happens now when I start the game. Start, start, start. So I'm pressing continuously here, and it is starting the game over and over again. So we don't want that. So we only want to start the game once, and then the game is started, and it needs to wait until it finishes to start again. So under this 13th line, we are going to go into the document and we are going to remove the same event listener we just made. So it's going to be on key down, and we're going to remove the start game. So now if I start the game once, and I'm continuously hitting keys now, it's only starting once, as we can see. Perfect. So I'm gonna remove the console log here. Then we're ready to make our actual game loop. So as we talked about earlier, we're gonna have a loop that is gonna create little snippets of time inside of our game. And within this game loop, we are gonna be iterating the position of the paddles and the ball. So we're gonna kind of increment where they are and also their speed every single loop. So first of all, we're gonna call that loop inside of our startGame function, game loop. So we haven't made that yet, so let's do that. Function game loop also does not take any arguments. Inside of the game loop function, we're gonna check if the game is running, because otherwise we're not going to do anything inside of the loop. So if the game is running, we are going to do things. Otherwise, do nothing. So let's just console log here. Game is running to see the actual incrementation of this game loop. But so far, there's no increment because we're just calling it once. And start game is only being called once. And then the event listener is being removed, and then we're calling the game loop. So this would just print once now. But if we also add, after this console log, we're going to add a set timeout. And then we're going to call the function we're in. And that is going to be after 8 milliseconds. Now, this is a function that is going to run infinitely. It's being called in the start game. It's logging game is running. Then it has a timeout that waits 8 milliseconds before it calls it again. Logs, calls it again, logs, and that's how it's going to go for all eternity, or until my computer turns off. So now if we save, and I'm going to open the console log here, I'm going to hit a button, and here we see. Now it is logging every single 8 milliseconds. And that is our snippets. That is our game time running as we speak. How cool is that? It's not very useful yet, but now we can imagine, okay, every time we run the game time, check if the ball has hit a paddle or check if the ball has hit the wall. Also move the ball based on its current position, you know? So now we're starting to get into actually movement and elements within the game. So I'm just saving to reset the game. Later on, we're also going to add an actual way to reset the game when it is playing, a way to stop the game. So I'm going to remove this console log and I am going to replace it with another function because we are going to update our paddle 1. And that is going to be the first paddle. That's going to be our left paddle that we are going to create a function for. So every game loop, we are going to be able to move our left paddle. So let's create that function now. Update paddle 1. We also need to add the function keyword before. It also does not take any arguments. And inside of here, for now, we're going to handle, eventually we're going to handle all the movement of the paddle. But for now, let's just console log paddle 1. And let's see that everything is working. Console, let's hit the start, paddle 1, paddle 1, paddle 1 for all infinity. Great. Hit save. Now we're ready to create the logic for saving the keys that we currently have pressed down and the keys that we are releasing. So that's how we're going to know. We're going to use the W and the S for the left paddle, and we're going to use the up and down arrow for the right paddle. And we need to know when are we holding them down and when are we letting them go. So we are going to scroll up. We're going to create a new variable using the let keyword. And we are going to call it keys pressed. And that is going to be equal to an empty object in the start. And inside of that object, we're basically going to add the keys that we are holding down or letting go. So they're going to be filled as we play the game. So now if we scroll down, instead of logging paddle1 as a string, let's log that entire object. So keys pressed. Okay, great. So now if we press, we see an empty object. Great. But now the cool thing is we're also gonna add some functions for this key pressed. So we're gonna say function handleKeyDown. Here we are gonna take an event as an argument, and we are gonna say keys pressed inside of this empty object. Go into the event. What is the event here? Well, it's gonna be the key that we're gonna press. And go into that key and set that to true. So how do we actually use this? Well, let's go up to the event listener here. We are going to create a new event listener that is going to run separately on the side for this start game. And we are going to listen to, again, the key down. But now we're going to call the handleKeyDown. So the handleKeyDown, as we can see, takes an event. What is the event? That is this event, the keydown event. So the document is listening for an event. It passes in a keydown here. And we are taking that event, passing it into the handleKeyDown in this event here. So here we are listening for a key. Let's say we hit W. Then we call the handleKeyDown. We send W here event. And then we say inside of this empty key pressed object, you're going to go and create a new index that is W. And you're going to add that there. And then you're going to say that that is equal to true. So let's see what that looks like. Here we are console logging keys pressed. So now if I hit W, we see that we have, and also let me scroll all the way up so then we don't have, in the start we see that it's empty. And then we have W set to true. So we have added the event W and set it equals to true. How cool is that? Now, if let's just refresh, if I hit S, W, you see that we have both S and W. So now we are separate keys that we are, and I'm hitting lots of different keys now. We are filling this object with lots of different keys. And now we're able to keep track of which buttons we've pressed. The next step though is to also keep track, because if you see here, W, I just pressed it once, but it's saying true, 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 true. I want to keep track of which button am I currently holding down. So we also need to handle the key up event. So if we go up here, we hold Shift Option down to copy the event listener. Here we're going to listen to key up instead. And here we're going to send in the handleKeyUp like so. It doesn't exist. That's why it's blue. So we are going to just copy this actually. Shift Option down. handleKeyUp. It is going to take the same type of event, keys pressed. It's going to go into the event key here, into W, but now it's going to set it to false. And watch what happens. So now I save. I hit W. And now I just hit it once, and now it's setting it over and over again to false. So if I hold it, it's true. Now I'm going to let it go. False. True, false, true, false. So now it's only going to be the current state of keys pressed is only going to show if I'm holding it down or not currently. Now I'm holding S. Now I'm holding both W and S. And now I'm letting both go. And now I'm alternating. So now we know which direction and when I'm holding them down. And this is getting us closer and closer to moving our paddles. Now let's close the console here. And we can get back into the update paddle1 function. So I'm going to remove the console log here. So now we're in our update paddle. So paddle function. So how are we going to make our paddle actually move? Well, we're gonna check inside of the paddle. We're gonna have a if statement. So we're gonna check if we press W or if we press S key. So that's gonna be for the left paddle. So if we press W, then we are gonna do some logic. And what is that logic gonna be? Well, we are gonna increment the speed of the paddle. So where does the paddle go if we draw it here? Our left paddle is going to go either up or down. The up is going to be with the W and the down is going to be with the S. So if we press W, how are we going to move the paddle? Well, we have to say that the coordinates, so the paddle 1, let's say, you're going to take the X coordinate of that and you are going to move it up. So you're going to take this and you're going to minus that by 1. And that will actually change this position of this paddle and we're going to move it slightly up. And that is the core of what we're going to do in this upgrade panel function. So if we press the S here, we are simply going to plus by 1. When you're doing math in school, you're used to that the x-axis goes this way and the y-axis goes up. But in HTML, the y goes actually down, so the plus direction is downwards. So if we want to go up, we have to go in the minus direction. If we want to go down, we go in the plus direction. For the x, plus is this way and minus is this way. So if we press W, then we want to somehow get to the point where the paddle keeps moving upwards as long as we hold the W down. But as soon as we let go, we want it to stop here. So how do we do that? Well, let's say if we press W, we're going to run some piece of code here. We're going to take the speed of X, let's say, and we're going to increment it by 1. Then the next time around, the speed here is starting at, the first round, speed is equal to 1 because we set it from 0. The second time around, it's going to be equal to 2. And then as we keep adding more speed to it, it's going to go faster and faster until we set a limit to 5 in this case. So we're going to increment the speed until we get to 5, at which point the paddle is going full speed. Then if we let go, if W, and remember we're keeping track if it's true or false. If it's false, then we're going to do the opposite. We are going to say speed minus 1. And then it's going to be equal to 4, 3, 2, 1, and 0. So this is how we're going to stop the speed eventually. So I hope that makes sense. We're going to use the same logic for both the left paddle, the right paddle, which are going to go up and down, and then the ball, which is actually a square, we are going to be able to move it in all directions. So up, down, right, and left. So in this way, we're going to give it an initial starting speed and starting. So initial speed. All of them are going to have that. The paddles are going to have speed equals to 0, speed equals to 0. This one is going to have speed equals to 2, let's say. Then we're also going to have acceleration, which is going to be equal to 1, 1, and the ball doesn't have an acceleration because it just has a speed and it's going at that speed constantly. And then we're also going to have a deceleration, which is going to be equal to 1 for both paddles. And again, the ball does not have deceleration because it's just going in one constant speed, that is 2. And then once we have the ball moving, let's say we start the ball sending it downward. So we send it in the plus x direction and plus y direction, which would make it go this way. Then we need to be able to figure out how do we actually know when it has hit the right paddle. In order to do so, let's draw our game board to visualize how the computer would think about it. So the paddle is going to be here, let's say, making it very thick so it's obvious where it is. Then the ball is going to be there. So how do we know when it hits the paddle? Well, we need to know when is it crossing this line here. So that means this is the x direction. And that means the x direction. So at which point does the ball x equal to paddle x, let's say. And then we know that we are here. That is this point. So now we have shut off this part. So we know when the ball gets here. But we don't know if the ball is on the edges of the paddle or not. So is it going to be able to pass here or here? How do we figure that out? So far we don't have a paddle, we have a wall. And we know how to say that this x position is the same as this x position. So now the next thing is, if we can figure out what's the upper side of the paddle. And then we take the y coordinates. So the paddle is somewhere in here. So if the top side of the paddle is, let's say, at y 3, then we know that this part is where the paddle is. And then the red part here becomes gone. Then we have decided two sides, and that is the blue top side and the red left side. Then let's say we also figure out the y coordinate of the bottom half of the paddle. Then suddenly we have all the coordinates for paddle 2. And now we can decide, is the ball, is the coordinates, the x and the y coordinates of this, does it match or is it overlapping the x and the y coordinates of the paddle? And then we can decide, is it a hit or a pass? And based on that, we can decide, is the ball going to change directions or is it going to keep going in the same direction? And this is true for if it hits the wall, if it hits the right paddle, if it hits the other wall, or if it hits the left paddle, or if it goes past all of them and goes beyond the border, in which case the other player has won. Back in our code, we want to go into the updatePaddle1 function. Inside here, as we just discussed, we want to check, have we pressed the key W for up for the left paddle? So how do we do that? Well, we're going to say if keys pressed, and then we're going to say if it contains a W, like so. So if there is a W key here, if there is an index that holds a W, then this whole if statement here is equal to true. Then we're going to try to move the paddle upwards. So here we're going to define a paddle 1 speed, and then we're going to set it to 5 just for the start. Or actually -5, because that's going to be if we are moving in the upward direction in the y-axis, it's going to be in the minus direction going upwards. So let's also define this variable here, because so far it is not defined. So let's scroll back up to our game variables. Let's define let, and just paste that in there. Paddle 1 speed is equal to 0 in the start. And moving down to our update paddle 1 function. So here we're setting the paddle 1 speed to the max of -5. So that's going to go full throttle right away from 0 to -5. And then we want to grab a hold of paddle y, paddle 1 y coordinate, and set that equals to paddle 1 speed. Now paddle 1 y coordinate doesn't exist either, so let's copy that and create a new variable that is going to be 150. So that is going to be in the center here, or actually the top part of the paddle. And we scroll back down. Then let's check if those coordinates are actually being updated. So we're going to console log paddle 1 y, like so. Let's inspect our console here. I'm going to hit W, and as we can see, it is incrementing and super fast. So we have successfully added coordinates that iterate and then negatively. So I'm hitting S, nothing is happening. Hitting all the other keys, nothing is happening. W, and we are starting to move upwards. So we're not actually targeting and updating the position of the DOM element. So let's do that right now. So instead of console logging, we can just remove that. So let's instead scroll up, and we are going to create a new constant here that we're going to define called paddle1. This represents our paddle in the JavaScript, and we're going to say that is going to be equal to document get element by ID, and of course that's going to be paddle1, and let's not forget the single quotes. So now we can use that down here. We can say paddle1 dot style dot top is equal to paddle1 y plus we need to add the pixels, because now we're just adding numbers like so. So let's test that. Starting the game, I'm pressing other buttons, I'm pressing S. Now I'm going to press W. Oh, hey, there we go. Let's reload. W. Cool. I find that super cool. Pressing other buttons, pressing up, down. Of course, none of them work because we only have taken this into account. So if key pressed W. So if we press W, the paddle is moving upwards. Awesome. Now, we don't really want the paddle to just start at full speed. That's going to be a bit of a choppy, movement. So let's, instead of putting it to -5 immediately, we are going to use the inbuilt math function here, or object. And inside there, we have a math function, a method, and it, as it says here, returns the larger of a set of supplied expressions. So you can give it 2 or 3, and then it's going to return the 3. If you give it -3 here, it's going to return the 2. So this is a very handy function that we're going to use to increase the speed of the paddle one step at a time, and to also cap the speed at a certain point. So for the first number, we're going to say paddle 1 speed. At the start, we have set that to 0. So we're going to say 0 here. And then we're going to minus paddle. And then we're going to make this as a new variable, acceleration. Well, actually, it's going to be a constant because we're not going to change that. It's going to have a constant acceleration. So let's copy that. And we are going to create a new constant here. And we are going to create a new constant. Game constants. And that is going to use const paddle acceleration. And that is going to be equal to 1. So we're going to accelerate by 1 pixel at a time. So now we can use that down here. So paddle speed is 0. Minus 1 means it's minus 1 when this is done adding together. And then here we are going to have our max speed, which we are going to set to minus 5. So in the first one, we have minus 1, and then we have minus 5. It returns the max. And the max of minus 1 versus minus 5 is minus 1. It is the highest number. And that's because these two numbers are in the negatives. So this all equates to minus 1. So after the key is pressed once, after the game loop has ran once, paddle 1 speed is going to turn from 0 to 1. The next time around this runs, it's going to be minus 1 here, and then minus 1, which is minus 2, and then it's going to compare with minus 5, which is going to equate to minus 2, and then minus 3, minus 4, and then when we hit minus 5, they're going to be equal, so then it's just going to return minus 5. And then when this turns into minus 5, minus 1, it's going to equate to minus 6. At that point, it's going to switch from this side to this side being the highest number. So it's going to return minus 5, and then it's going to like stagnate there and always be returning minus 5 from then on. And that is how we cap our speed at minus 5. And of course, instead of writing minus 5 here outright, we are going to say minus max paddle speed. Speed, like so. And let's also create that as a constant. Constant max paddle speed equals 5. So then when we use these in several places in our code, we don't have to keep, if we ever want to change them or update them, we can do it in one place. So that is taking into account the W. If you pay close enough attention, you can see that we have a bit of an acceleration instead of immediately starting at full speed. Then what happens if we press S? Well, we want to go down. So we're just going to flip this essentially. So then we're going to say this is an if statement, and then else if keys pressed is equal to S, then we are going to run a similar piece of code. Let's copy that. So paddle 1 speed is equal to math, but here it's going to be min. Because here we're going to want to get the smallest number. Paddle 1 speed is going to be the same, and here it's going to be plus. Like so. And then it's also going to be plus for the max paddle speed. So what does this look like? Well, when we have 0, this is 0 initially, and then this is 0, and then it's going to be plus 1, so that's going to be 1, compared to 5. And the minimum value of 1 and 5 is 1. So this is winning. Next time around, this is 1. This is going to be 1 plus 1, 2. Again, winning against 5, so it's going to be 2. So it's going to go in the pluses. 1, 2, 3, 4, 5. It's going to go to 6, and at that point, it's going to switch and return the max paddle speed. So it's really just the opposite of the W. So let's see how this plays out when we start the game. W, S, A, we can actually turn our paddle. Of course, it's going infinitely high and low, and it's not being stopped by the borders because we haven't added that logic yet. But already this is pretty cool, I find. And if you pay close enough attention, you can really see the acceleration and deceleration. Or actually, we don't have a deceleration here, which is what we're going to create right now. Because now if I just press the S key or the W key once, the paddle is going at max speed. But we want to actually have the paddle move only as far as I am pressing the key. Otherwise, we want it to slow down when I let go of the key. So let's add that functionality now. We want to add a third else here, or a second else. So if the key press W or S is not pressed, we want to run this code. And we want to check if paddle 1 speed is larger than 0. Then we're going to run another code here, and we are going to say paddle 1 speed, and you're going to take math again, max. So we're going to return the max of two numbers here. First one is paddle 1 speed minus paddle acceleration and 0, because 0 is our baseline. So if we are, let's say, at 5, which is going to be the case most of the time when it's moving, then it's going to be larger than 0. Okay, so that's true. So we're going to run this. Then we're setting paddle 1 speed to the max of this one and this one. So paddle 1 speed is 5 minus paddle acceleration, which is 1. That's going to be 4. And that is higher than 0, so it's going to return 4 here. Next round, it's going to return 3, and then 2, and then 1, and then 0. And at that point, it's going to stop. Of course, this is not really correct wording, so for the sake of having correct syntax here, we should actually create a new constant here, even though they're going to be the same. Call it deceleration, like so. And then let's copy that, go up here, const paddle deceleration is equal to 1. Just in case we want to in the future put these as different numbers, it's good to have that as a separate constant. Okay, so now if I press the S key, we can see that it is stopping in the W direction, because that is a negative direction. We still are going infinite, but now I'm holding in the S, I let go, it stops. Now I just press the W once, it keeps on going forever. So now we have deceleration and stopping in the plus Y axis. Awesome. Then we're adding another if or else if here. Paddle 1 speed is lower than 0. We are really just going to run the opposite again. So let's copy the code. So paddle 1 speed is going to be math min paddle 1 speed plus paddle deceleration. And that's going to give us the other direction. So now I'm holding them in and I have full control of the paddle. Awesome. That is satisfying. Next thing to add now is to add our borders so we can actually cross these walls, because now we're just like being able to go way outside the border. So it looks good here, and then we should stop here, right? And on the bottom. So let's add that. Right after the paddle speed here is added to the coordinate, we want to add another if block here. So here we're going to check if paddle 1y is smaller than 0. So that means if it's higher up, like here, it's 0. If it's higher up than here, we're going to run some code. Then we're just going to set paddle 1y to 0. So basically, if we go to -1, it's still going to just be reset to 0. And if I hold the W in now, hey, I can go higher up. So it's quite a simple block. Then we're going to do it for the opposite side as well. If paddle 1y is larger than, and then we're going to put some new constants here, game height, which we're going to create. So what is the game height? Well, it's, let's see, game constants, const, game height is equal to 400. Because if you remember in our styles, I'm just going to search that, 400, Control F, that searches. We have our game area, height 400, and the width is 600. Back in our script, so yeah, we put that to 400 correctly. Let's also just create the const width while we're still here. Game width equal to 600. Then we can move down again. So if the game height, if the paddle 1y, the coordinate of the paddle in the y direction is bigger than the game height, but remember the coordinate we're talking about is the top part here. So we need to account for the height of the actual paddle. And the way we do that is we do minus paddle 1, and then we can go into the actual DOM element, the HTML element of it. And there is an attribute here called client height that all HTML elements have. So we can access that. So that is going to be the actual height of the paddle. So initially we're here on this spot here, and then we're going to move down there. So we're actually correctly getting the exact spot we need. So basically what we're saying here is if the paddle height, which is here, is lower than here, minus the paddle client height, which is there. So that's going to be the correct spot. So we're actually checking somewhere here. Then we're going to take the paddle 1y. We're going to set that to the game height minus the paddle 1, just paddle 1, client height, like so, which is still going to give us the furthest down position to reset it to. And as we can see, when I start the game, we can't move beyond the border. And now we have successfully enabled movement and limiting our paddle position. Awesome. Now that is everything we need for paddle 1. And luckily, paddle 2 is exactly the same, or almost the same. So let's just copy this whole function, paste that there, and then let's use Control D to target all the 1s and change them to 2s. Like so, 2. And now we have to also make these variables. So paddle 2 speed, let's copy that. Let paddle 2 speed, we're going to set that to 0 in the start as well. We also need let paddle 2 y, 150 as well. And let's scroll down. Did I not just create paddle 2y? Paddle 2. Missed the 2 there. We also need to actually create the DOM element to reference it. So paddle2 itself, up top, const paddle2 equal to document get element by ID, and that is going to be paddle2. So now if we go down again, we can also close by clicking this arrow here, paddle1. It's a bit easier to see our code. So now instead of key pressing W in paddle2, we want to say the up arrow. So that is going to be arrow up, and instead of the S, it is going to be arrow down. This code stays the same. So does this one. So do these code slices here, and actually everything else. So let's try that now. So W, that works. And then up and down doesn't work, of course, because we haven't called this function update paddle2. So let's go up to our game loop and just update that there. Call it right under paddle1. And then let's start our game again. W, S, up, down. Perfect. We got our second paddle working. Awesome. Then we are ready to make our ball move. So let's go up to the game loop and let's call a new function that we're going to create called moveBall. And we can scroll down to the end here. We can close our update to paddle2 as well and create a new function, call that moveBall. And inside of here, we are going to target the ball X coordinate. So let's create that. And we are going to set that plus equals 2. So we're setting it to ball X plus the next thing we write here, which is ball speed X. So let's go up and create both of these two. I'm going to copy them from here. So these are going to change, at least the let ball X, and that is going to be equal to 290 in the start, which is the game width divided by 2 minus the ball width, which positions this in the center. And then we are going to have the let ball speed X is going to be equal to 2. While we are here, let's just copy those, and we are going to do the same for the Y. The position for the Y is going to be 190, and the speed is going to also be 2. Then we can move down here again. We're going to say ball Y is also plus equal to ball speed Y. So for every game loop, we're going to iterate the ball speed, and originally it's just going to be in the plus direction both ways. So it's going to go to the right and to the left down. So let's start. Of course, we are not moving the actual DOM element, so that's why it's not moving. So we are going to call a new constant, which is ball. So let's create that right now in the top. Constant ball equal to document get element by ID, and that is going to be ball. Then inside of our moveBall function, we can say ball dot style dot left is equal to ball X plus pixels. And we're going to copy that down and say ball style top is equal to ball Y plus pixels. So now we see that the ball starts moving in the plus direction of X and Y when we start the game. Of course, nothing is stopping it from just continuing infinitely, just like the paddles initially did. So now we can focus on setting up the logic to actually make the ball move and bounce around in the game area. So first off, let's create the rule for the bottom and the top wall. So here we're going to write an if statement. If ball y is bigger or equals to the game height minus the ball dot client height, or the ball y is smaller or equal to 0. Then we are going to set the ball speed of y equals to the opposite. So we're going to change directions. So ball speed y. So what does this mean? Well, let's break it down. If ball y, that is the position, is bigger or equals to game height, so that's the whole height, minus the ball client height. So bigger or equals to means that it's gone below or at the edge of the bottom border, minus the ball client height, so it's not past the border, it's just before, or the ball y is smaller or equals to 0, and that is the top border here. So now we're defining between the bottom and the top border. And then we're gonna just reverse the ball speed. So let's see what happens. Start the game, and we see that the ball is reversing its speed. And now it's just bumping between the walls here. So that is working as intended. Now let's create the rules for bumping into paddle 2, which is the right paddle here. So if the ball x is bigger or equals to the game width minus the paddle 2. Let's see, just paddle 2 client width minus the ball like so, and the client width of that. So here we have the left side of the paddle that we are checking. So if the ball x, the position of the ball, crosses here the game width, here, the total game width, minus the paddle width, so that's here, minus the ball client width. So the ball is not passing, but it's just before, so here. That is giving us the border here. Perfect. What do we do then? Well, we're going to take the ball x speed, and we are going to reverse it. Like so. So let's check. And that is successfully reversing our ball. As we can see, we replay it. It works every time. Perfect. But that is not our paddle. That's just kind of a wall. So we have to make sure that it only also accounts for the top part of the paddle and the lower part of the paddle. So we are going to add on to this if statement here with a AND statement here. So double AND. So then the second thing that needs to be true as well is ball y needs to be bigger or equals to paddle 2y. So here we're saying the ball y position, which is up and down, also needs to be bigger or equals to paddle 2y. So it can't cross above here. So now we have this whole section accounted for. So now we need the last and third one. If ball y is also smaller or equal to paddle 2 y plus the paddle to, let's see, paddle to client height, like so, which is giving us the bottom position, because paddle 2 position is here, y, plus the paddle height is down here. So now we have defined the 3 coordinates for the paddle that we need to define the whole paddle in according to the ball. So now let's see if we go past. So now let's see if we go past the paddle. Yeah, it is not hitting. Cool. It is hitting something behind there, which we haven't accounted for, but that's okay because that's not going to be a problem in our game. But as we can see, the paddle is not, yeah, it's because it's turning on the bottom and top part of the paddle. But as we can see, it is not actually being stopped by the paddle. So let's hit it with the paddle. That is stopping it. So if we hit the ball with the paddle, we are changing the direction. Perfect. Now let's copy this whole part. And we're going to change the paddle 2 to paddle 1. So paddle 2 here, Control D, and we're going to change that to 1. We are also going to tweak these a bit. So paddle X, we only need the paddle client width here, like so, because that is the only thing we need, because 0 starts on the far edge, and then we just need the width to tell us where the paddle is and according to the X axis. As for the Y, we want the same thing, ball Y, as long as it's bigger or equals to paddle 1Y. That's going to be the top of the paddle, and the bottom of the paddle is going to be ball Y smaller or equal to paddle 1Y plus paddle 1 client height. So that is correct. So now let's try to actually play a bit back and forth. Okay, so we actually have a bug here. Let's figure out why it's moving strangely. Let's also comment a bit. Paddle 1 movement, or collision actually. And then this is paddle 2 collision. Here we go. It's in the first line. We want to check if ball X is smaller or equal to paddle 1. Let's check now. If we start the game, and here we go. That was the fix. And as we can see, we're playing Pong. Cool. And then if I let it slide beyond the game, it is going beyond there and it's being stopped somehow. But that is cool. Now we can move on to handle the loss scenario when we actually move beyond the wall. Then after this if statement of the paddle 2 collision, just before we set the new coordinates in our HTML, we are going to handle the out of game area collision. So here, if ball X is smaller or equals to 0, so that is when it goes on the left side out of the game area, how are we going to handle that? Well, first of all, we're going to take player 2 score, and we're going to increase that by 1. So we haven't made that yet, so let's do that now. So if we go up to our variables here, let and then copy that, player2 score equal to 0 at the start. And let's just create a new one. Let player1 score equal to 1. Actually, 0. You don't get a point just because you're player 1. Then let's move down again. If player 2 has scored, we also need a condition for player 1. So we're going to say else if ball x is more or equals to game width minus the ball dot client width, like so, because we want to handle the width of the ball again. Then we are going to take the player 1 score and we're gonna increase that by 1. Then we are gonna call as well, we're gonna update the score, because now we just have updated the score but we're not showing it, you know. If we now see here, we're not showing that score anywhere. Okay, so we are gonna call a new function that's gonna be called update scoreboard, like so, and we're gonna call that regardless of which player wins. So let's make that function right here. Function update scoreboard. We're gonna take player 1 score and we're gonna create a DOM element that represents the text that we have here. And we are gonna go into the text content of that element. And we're gonna set that equals to the player 1 score. And we're going to copy that down, and we're going to do the same for the player 2. So copy the 1 and just paste 2. So now let's create these elements here all the way up. I'm going to create 2 new constants. Const player 1 score element equals to document dot get element by ID, and that is going to be player 1 score. The exact same for player 2, Command D, and change that to 2. Okay, so now if we play the game and we let the ball go, we see that it's iterating really fast the score here. So player 1 has soon 1,000 points, and we're going more and more. There we go, past 1,000. So obviously we want to just do that once. So that is why we are also, in addition to updating the scoreboard inside of the moveBall function here, we also want to reset the ball so that it is in the starting position for both these conditions. And then let's create that function here. Function reset ball. We're going to take ball X position. We're going to reset that to the game width divided by 2 minus the ball client width divided by 2. And we're going to do the same for the Y direction. We're going to say game height divided by 2 ball client height. And this essentially resets the ball into the center of the game area again. Then we're going to take the ball speed X, and we are going to randomize the direction so that it doesn't always start going in the towards the bottom right corner. So we're going to say math and then random, and that is going to give us a random number between 0 and 1, as we can see. So if that is smaller than 0.5, which is going to be about half of the cases, then we're going to say, if that's the case, if it's bigger, than 0.5, then give us 2 as the ball speed. Otherwise, give us -2. as a ball speed. And then we're going to do the same exact thing for the Y speed. So now we're resetting the ball. So let's play here. As we can see, the ball is reset and starting from the first position. Then now we need to also pause the game so the ball doesn't just keep running and resetting from the center, because we want to be able to pause the game and start again on key press. So let's also call the pauseGame function here. Let's copy that down, paste that in both instances. And then after our resetBall, we want to have another function, pauseGame. So we're going to say game running is going to be equal to false, which is going to stop the whole game loop. If you remember up here, if game running, we're going to go through the loop, but if it's not running, nothing is going to happen. So essentially that stops everything from moving. Then we're going to also go into the document. We are going to add event listener, and we're going to add again the key down and listen for the startGame function, because otherwise we wouldn't be able to start the game again after one round. So now let's see what we have. Okay, we are playing. We are bumping the ball between the paddles, and then now I'm gonna let one pass. Hey, player one got a point, got another point, got a third point. As we can see, we're also randomly getting directions for our ball. Player two got a point, player two got another point. Hey, there we go. Now we are playing Pong. But there is a crucial aspect here missing, and that is the game sound. And I find that makes a very, very big difference of the feel of the ball actually hitting the paddle and the walls. So then let's create the last function here. That is going to be play sound. And we're going to play a sound. So this function takes an argument. We're going to give it which sound to play. And then first we're going to take that sound and we're going to stop it in case we're already playing it, because that can create a bit of a buggy sound, and one might not have fully played, and it might kind of overlap each other. So we're going to reset the sound in case we're already playing it, and then we're going to say play this sound, which we're going to use the inbuilt sound method here, which you can use for audio files. So now we're going to use this play sound function inside of our moveBall function here. Whenever one player scores, it means we also need to play that sound. So play sound, and we're going to pass it the loss sound, which we need to define. And that is going to be true for both cases. Now let's define that sound up top. It's going to be constant loss sound equal to document get element by ID loss sound, like so. Let's also create the sounds for our other two instances, the wall and the paddle. So wall sound, and that is going to be equal to this syntax here. We're just going to say wall instead, and then copy that down. Target wall, and we're going to say paddle, like so. Now down in our moving ball function. So now we're sending that loss sound in here, and it's playing using the function. So let's check. So as you can hear, I hope you hear the sound. We get our loss sound. Okay, then let's go up to our paddle here, let's see, inside of our moveBall function, if it collides with paddle 1, we want to play the sound and we want to play the paddle sound. And let's copy that also for paddle 2. And then if we are hitting the wall here, wall collision, we are gonna play the wall sound. Okay, so now let's check out, play again. Awesome. Cool. Okay, so there we have our game ready to play. And as we can see, if a player wins, the other one loses. And our score keeps iterating. Awesome. Now I'm going to show you if you want to change the sound to something you would rather use or just have a different sound, how to do that. So we have our sounds in our assets here. So if you visit musiclab.chromeexperiments.com, then you're going to get to this site. I'm going to leave this link in the description below. You're going to click the song maker, and this is exactly what I used to make these sounds here. So this lost sound, the wall, the paddle. I'm basically, so here we can see, if I click one here and I hit play, we get this pattern. So we can also change this to different sounds, blocks, kit, conga. I think I used electronics. And it's about there for the paddle sound. Also the tempo I put quite high. And then instead of marimba, we change that to synth, and there you go. So you can play around with the different tunes here. And you can even change the octave. So that's kind of a paddle sound. And then the wall was a bit more down here. And the loss was all the way down. And once you find a sound that you actually like, you click save. And now you can download the WAV file here. And if I just put that into our project here and play it, you can see that that is quite similar to the wall sound, I mean the lost sound, just that the lost sound was a bit longer. Let's see, the tempo was lower. Even lower, maybe 60. There we go. About 60, 70. So there you go. That's how you make, and for the paddle and wall, I had a higher tempo. So now to deploy our website. So what we're gonna do is we're gonna save all of our files here, and then we're gonna open back our Github Desktop, which has been keeping track of all the different changes that we have made in our project. So we're gonna write a commit message here. I'm just gonna write finish Pong game. I'm gonna commit to main. I'm gonna push origin. So now that is saved in our GitHub account. And if you want to see it, you can click this view on GitHub. So there it is. Then we're going to open netlify.com. We're going to create an account if we don't already have one. And we're going to log in here with our GitHub account. And it's going to look a bit like this. We are going to click this add new site, import an existing project. And we're going to choose GitHub. That's going to authorize from GitHub, and you're going to have to give it authority if it asks for that. Then we're going to search for our repository, Pong. Here it is, Pong game. It's public. I'm going to give it a site name. So that's going to be the URL, the best Pong game on YouTube. So that's going to be the site URL. You can check the availability. That is available, oddly enough. Then you can leave all the other settings by default. You're going to scroll down and click the deploy button. And that is going to take, you know, a couple of seconds up to a half a minute or so. This is not a very big site, so it's going to be very fast. And then it turns green when it is ready. So if we click that, we see the best Pong game on YouTube.netlify.app. It is hosted. Press any key to start the game. And there we go. We are live and we are playing. This is truly a fun game. Like, I'm actually enjoying playing against myself here. Okay, I'm gonna let myself win or lose. So yeah, if you enjoyed this game, please let me know in the comments what kind of games or apps you would like to see in the future. And if you like this video, you might like this other one that I have suggested for you right here. And as always, I'll see you in the next one.